Hello everyone. Today we'll be discussing about HTTP2. Mm, HTTP2 was developed in 2015 October. Actually, it is the Speedy protocol. They updated the Speedy protocol, which was developed by Google, and then we got HTTP2. So before getting into HTTP2, it's important to understand what HTTP is. Okay, so HTTP, according to my understanding, is I considered HTTP is a courier service. Let's say I have a resource at point A, and I want to send that resource at point B. So in order to uh, send those resource at point B, I need to have some courier service which can deliver it to point B. So HTTP is not only limited to sending resources. If you get into HTTP methods, there are many methods. You can get some resources. We have get method. You can post something to a point B. Okay, so we have post method. You can delete anything from point B. So uh, these are the methods of HTTP. Now, if you see HTTP in the layers, it comes in the application layer. We all know TCP. TCP is in the transport layer, and then we have this optional session layer. Okay, one thing to understand is HTTP is a stateless protocol. We will need this term stateless protocol in our coming slides. So we need to understand what stateless protocol is. Stateless protocol is nothing but it it does not remember the state. Let's say I made a get request, okay, and then I made a post request. So while making post request, it won't remember that it had made a get request. Okay, so this is what stateless protocol is. Now this is a simple example, a simple get method example, where if I want to fetch index.html from some domain.com, okay, so what I will do is I will send a request. We'll be sending request in a form of header, request header. Okay, so request header will look like this. First you see a get method, then the path which is index.html, then HTTP version which we are using, that is HTTP 1.1, then user agent is Mozilla something, then host where you want to make the request. Then you have accept language, which language you understand, so you can mention that as well. Okay, so this is an overview of request header. Once you have made request to the server will respond back in the following form. You see it has responded with status code 200, which is okay. Okay, and then date and last modify, and then at the end you will have message body. So message body will be followed by response header. So you'll have response header, and then you have message body. Message body is nothing but the index.html which you had requested. Okay, so this is a simple example of HTTP GET method. Okay, now we have understood what HTTP is. Now we need to understand why we had to move from HTTP 1.1 to HTTP 2. Okay, so first thing is speed. See, today the web is not only web, it's getting bigger and bigger in size every day. So it's very important to have a good speed, because today speed is business, speed is money. If you are good in speed, you are good in money. So everyone needs speed. But there were some issues in HTTP which were creating problem, HTTP 1.1, which were creating problem. If you see this diagram, if you see this figure, in HTTP 1.1, we were able to make one request at a time and then wait until we get the response. Then only we were able to make request 2. So it's like time consuming. Until and unless you get the first response, you cannot send the second. So it's like you can make only one request, and then you can't make multiple requests in HTTP. But it was solved by pipelining. We'll get into that. Okay, so what they started doing is they started with few hacks. First is like, if you see one of the hacks, okay, it's domain sharding. Domain sharding is nothing but, see, I can make only one TCP connection. So in domain to domain.com, let's say domain.com. So what I will do is, I, instead of making one TCP connection to domain.com, I will make several 4 to 6 connection to domain.com by dividing it into subdomain. Let's say I will tell image1.domain.com, some.js, some file.js .domain.com, some file.css.domain.com. This is domain sharding. So instead of having one connection, I will have multiple TCP connections. Then we have image spriting. Image spriting, if you see a web page, in web page you will have several images. In order to get those images, I will have to make multiple requests. So what I will do is, I will combine those images as a single image. So whenever I will, so that way I will have to request only once, and I will get those images. Then we have something called concatenation. Concatenation is nothing but, if you have index.html, JS and CSS, so instead of having multiple files, you'll concatenate into a single file, and then you'll have a single concatenated file. We have another important thing, which is pipelining. So first, let's understand what pipelining is. So I will give you an example what pipelining is. Pipelining, let's say I have a plant, a bottle, a mineral water plant. What it does is, it will take a bottle at phase 1. It will fill the bottle as phase 1. Second phase, it will put the cap on the bottle, and third phase, it will put the logo on the bottle. So we have 3 phase in total. So instead of like What generally what happens is I will send a bottle. First it will get filled 1 minute. Second it will get you'll put cap on that, second minute. Third you will put a logo on that, third minute. So total 3 minutes. So while the bottle is being filled, the cap area, the logo area, the phase 2 and phase 3 is doing nothing. So what pipelining does is pipelining, it will make use of all the resources that is available. So what I will do is I have a bottle being filled, it will move to the cap area, then I will add one more bottle which will get filled, and then they will again move to the first bottle will move to the logo area, second bottle will come on to for the cap, and third bottle will start getting filled. This way all the resources are being utilized. This is pipelining. So pipelining allows us to, if you see here, pipelining allows us to, if you can see here, pipelining allows us to send multiple requests at once, and we can obtain multiple response. But there is one issue with the pipelining. That issue is head of line blocking. What head of line blocking is? Head of line blocking is nothing but, see, even in pipelining, it follows order. Let's say I have one 2 kb file, then second is 2 MB file. So if in the request, the first request is like for 2 MB file, okay. So until and unless that 2 MB file is obtained, I won't be getting 2 KB file. I can make multiple requests, but until and unless the 2 MB file is finished, I won't be able to get 2 KB file. So that is one drawback of this pipelining, and that introduces a time lag which you can see, and this is what we call head of line blocking. Okay, now, and moreover it had a poor support by browsers and server. Pipelining had poor support from the browser and server. Then second issue which we had with HTTP 1.1 was security issue. There was one crime attack done in 2012. We'll see how that attack was done with the compression technique which was being used by HTTP 1.1. Then intelligence. Third thing is intelligence. HTTP 1.1 do not have intelligence. So two things are there why we say it is not intelligent. First is packet streaming management. We'll see what stream is. And then correlation. We will see the correlation as well. Okay. Now we'll get into what HTTP2, what are the features of HTTP2. But before getting into HTTP2, it's important to understand that we are not redefining a protocol. We are not getting a new protocol. Your existing application will work. We have not changed the methods, the normal methods, status codes, headers. See, they aren't replaced. So normal application which are written HTTP 1.1, that is okay, and there is nothing, no changes is to be made there. So what we are changing is how it gets on the wire, how things are being transmitted. This is what we have changed. Second thing is version identification. See, URI scheme, we have two URI scheme. One is HTTP, one is HTTPS. Let's take HTTP. So in HTTP, if I'm not sure whether the server is whether some end is using HTTP2 or not, what we will do is, while sending the request in request header, we'll use upgrade H2C tag, key value upgrade H2C. So what upgrade H2C will do is, in case the other end supports HTTP2, it will send back and HTTP2 and then the connection will see, while making a request, I'll be making HTTP 1.1 request with upgrade H2C key value pair. Okay, while making the request, if I am not sure whether the server supports HTTP2 or not. So in that case, I will be making a request with upgrade H2C key value pair. So on the server side, if it supports HTTP2, it will respond back with HTTP2, and then the client can will understand that it supports HTTP2 connection, and then HTTP2 connection can be established. In case the server does not support HTTP2, it will ignore the upgrade H2C tag, and then the server will the server will ignore H2C tag. Okay, see that this thing is not similar with HTTPS. There are few differences regarding this thing in HTTPS. Now, getting back to the features of HTTP2. See, there are around 4 features, not 4, there are more features, but I'll be dealing with these 4 features. First is multiplexing, second is server push, then header compression and binary protocol. We'll deal each features one by one. Okay, but in number 4, binary protocol, if you see binary protocol, what it is like, if I say 3.1475, so I can either store this as a text, characters, okay, either store this as a characters, or I can store this as a floating point. Normally in our previous protocol we used to store this as a text. So that way, if I say 3.1745, so I'll need 6 bytes to store this thing. But if I say floating point, so I just need 4 bytes to store this thing. So that is difference between text and binary protocol. Okay, so this is binary. We have made this binary. So we won't be dealing with text. Okay. There are few terminologies which we should understand before getting into features of HTTP2. Those terminologies are streams and frames. Okay. Streams, if I normally think of stream is nothing but a simple flow, stream, river, a simple flow of something. River, we have water. In this stream, this is flow of binary data. But here the binary data is divided into frames. So each frame will have binary data, and then these frames will flow, which we call stream. So there can be, in HTTP2 we have only one TCP connection. Okay, and within that TCP connection we can have several streams, and that several stream, within several stream will have frames. So each stream is there can be several streams, but they are independent of each other. First thing. Second thing, they are bidirectional. So in a stream, if a frame is being sent to the other end, similarly the other end can send back some response within that string. So it's a bidirectional. A third thing is, this is virtual channel. Okay, if you, this is not an actual connection, but this is just a virtual channel. Okay, and as I told, a TCP can have multiple streams, multiple concurrent streams. Okay, and then within a stream, the order is very important. First, in order to open, see, data frame we'll be discussing, but simple thing which you need to understand is the order in which frame is being sent in a stream is of importance. We need to send the header frame first, and then we will be able to send data frame. Okay, then each stream will have its own stream ID. Okay, that is how we'll identify stream ID. The stream initiated by the client side will have odd number stream ID, and the stream initiated by the server side will have even number stream ID. Okay. Okay, see, this is simple understanding of what stream is. Stream is a virtual channel, no doubt on that. So if you pick into a stream, you will see binary data. Okay, binary data. So it is not an actual connection. Okay. Okay. Now frames. See, frames is nothing but it's the smallest unit of communication. The smallest unit of communication. So stream will have frames, and frame is obviously the smallest unit of connection. So if you see the structure of frame is like it will contain 9-octet header field, 9-octet headers, and then a variable length payload. Payload is nothing but the actual data content of the frame. Okay, and then you see there are few things like type, flag, stream identifier on the header. Type of frame, there are many types of frame. Okay, and then flags, we have few flags. Let's say example, end headers, end stream. In types of frame, we'll discuss few types of frame such as data frame, header frame, RST stream, priority frame, push promise frame. You shouldn't get confused between header and header frame. Okay, you shouldn't get confused. Those two are different things. A header frame, let's say a header frame contains header plus payload. Okay, so what is a payload in header frame? Okay, see, as we have already discussed, a header will contain not the header of frames, the actual header. If you go back, see here, let's say request header. See, the request header will contain some key and then their values. What I will do is I will compress this thing. Okay, I will compress this thing, and if the header is big, then what I will do is I will divide it into different fragments. Okay, so once I have divided it into different fragments, now this thing, all the fragments are called header block. Now this fragment is the payload of header frame. Okay, what we have done is, let's say something like request header. Request header, I will compress it and I will divide it into different fragments. You might have only one fragment, not an issue, but that fragment is the payload of header frame. In case you have many fragments, those fragments will be payload of continuation frame. Okay, which will be sent along with the header frame. First header frame, then continuation frame. Okay, then we have data frame. Data frame is the frame which contains data. Okay, the actual response which you have requested for. And the payload of data frame will have the data, okay, which we requested for. Earlier we requested for index.html, so it will have those data. Now stream identifier, 31-bit stream identifier is nothing but the stream ID, and each frame will belong to a particular stream. Okay, so it is important to identify which stream it belongs to. And flags, see, flags is like, earlier we said I will compress the header. Let's say request header, I'll compress it, break into different fragments, and then I will send it with the header frame continued with continuation frame. But it is important to know which is the last fragment, right? So we use this end headers that will tell us that this is the last fragment of the header block. Then we have something called end stream. We'll know about end stream once we get into server push. Okay, these are the frame types, many types. Okay, and then one more important frame is setting frames. Before we start the connection, it's important to know that what type of settings we expect. Okay, what will be the concurrent streams, okay, and what will be the initial window size, max frame size, okay, header list size. This thing will be sent through the setting frames. Okay, then we have window update frame. We'll see these frames in detail. See, this is the overview of the process. What we are doing is, we have some HTTP request, we are dividing it into frames, then we are assigning stream ID to these frames, and over a single TCP connection, we are sending these frames. Okay, and then we are getting a response which is in frames. Okay. Okay. Then we will come to multiplexing. What is a multiplexing? Multiplexing is, see, we are sending frames in a single TCP connection. No doubt on that. So in multiplexing, what we are doing is we have multiple streams. Okay. So in multiplexing, what we are doing is we are interleaving the streams. I have stream 1, stream 2, stream 3, stream 4. I will interleave these streams, and then it will be sent in the TCP connection. Again, TCP is also a bidirectional connection. You can send and receive at the same time. Okay. So one thing to notice is like this solves the head of line blocking problem. Okay, this solves head of line blocking problem by, say, if you have sent multiple requests, you won't have to wait for the first response to finish. Okay, you can have, if it is 2 KB file and then second is 2 MB file, whichever gets processed first, you will receive it. Okay. So one thing is of importance. We are having only one TCP connection. Earlier we could have had 4 or 6 TCP connections. So isn't the bandwidth an issue? See, as far as if you see the daily use, we deal with files which are of small sizes. So we are not concerned about bandwidth more, we are concerned about latency. We don't want any latency or delay in the communication. So that is why it's important to have a better speed. Okay. Of course, if you are dealing with a big file, then bandwidth will be an issue in HTTP2. Okay. Then we'll move to flow control and error handling. Okay. Flow control and error handling is an important part of the HTTP2. Flow control is nothing but it saves the endpoint from not being able to process the frames. There might be case when the frame when one particular endpoint is not able to process if the size of frame is more than the particular value. So the client, let's say client will tell the server that I can't process more than this particular file size, so I will set the file size to this value. Okay, and then server will respond accordingly. Okay, the default value of flow control is 65535 octet. Okay, then we come to error handling. Error handling is like, see, we have, do not get confused between the connections. There are two connections. First is a TCP connection. Second is streams, a virtual channel within a TCP connection. So whenever we'll be dealing with, we'll have stream and then TCP connection. So the error can be like the either the complete TCP connection was brought down, or there was some error with a particular stream. Okay. So in case we have some error with the TCP connection, okay, we can have go away frames that will have detail about the type of error that happened. And then we have something called RST frame, RST stream frame, that will deal with the stream errors. Okay. Now we come to server push. Server push is an important feature in HTTP2. Server push is nothing. Let's say I request for index.html. A client requests for index.html, but the server can with the help of correlation can tell that the client needs JS and CSS file as well. So what the server will do is, server will send a push promise frame. It is not sending the CSS JS file. What it is doing is, it is sending a push promise frame. Now the push promise frame will be sent to the client, and once it's like notifying the client that, see, you might need JS and CSS file as well with this index.html, and I intend to send those files with a stream ID which I have mentioned, and those information will be contained in push promise frame. Now it's up to client. Client will if the client wish to cancel receiving those files, it can send RST stream frame. Okay, RST stream frame will cancel the request of receiving those files. Okay, and it is clear that a client cannot send a push promise. Okay, it cannot send. Okay, then in server push we have two things. First is push request, then we have push response. Push request is nothing but sending the push promise frame. Okay. Yes, in push promise frame we'll be telling the stream ID which has been reserved, and the server will be sending files through that stream ID. Okay. Then we have push response. Push response is the actual response which has been initiated by the server. Okay. And one more thing, we are dealing with concurrent streams, concurrently open streams. So the client can use this setting max concurrent streams, okay, to limit the concurrent streams that will be open. Okay. Okay. This is the stream states. Do not get confused with TCP connection states. Do not get confused. Earlier I said there are two connections. One is TCP connection, then we have stream. Okay. See, if you see this state, in the early phase, the stream will be in idle state. Okay, now in idle state, the server like can send a push promise and a client can receive a push promise. On the left side you see send push promise, and on right side you see receive push promise. Both will lead to the change in state of the stream. Both will lead to move to a reserved state. If you see reserved uh, remote, it's nothing but it has been promised that it has been promised some resources, some files. Okay, that is what reserved remote is. Okay, now in case the you see left side reserved local is the same way, okay, as reserved remote. It reserved local, it had sent a push promise frame, okay, and it is in reserved state. Now it will send some header, okay, and the client on right side, okay, will receive header frame, okay. So here it can be, and both of them move to half closed state. Half closed state is nothing but you have very limited options. You have limited options where you can have only limited, you can only receive or send limited frames. Okay, and in this case, if you receive in stream or RST stream frame, okay, then it will move to closed state. Stream is closed. Yeah. In reserve state also, if you receive or send RST stream, you can go to closed state. Now we'll look at the center of this state diagram, which is idle to open to closed. See, if a stream had sent some, see, the one thing is to notice is like if a header frame contains end stream flag set, it can cause two state changes. The state change will happen twice. Here it can, if you have send a header frame which have end stream, then from idle it will go to open, and open to it can go to half closed, and from half closed local it can, if you send or receive any RST stream, it can go to closed state. Where is data frame here? See, data frame can only be dealt with when the stream is open. So when it is open, then only you can send receive data frame, but it won't cause any state change. Okay. Okay. This is all about stream states. Now this is an interesting topic, which is header compression. Earlier in HTTP 1.1, we used to have something called deflate, which was combination of LZ77 and Huffman algorithm. The gzip is like it's using this thing. Okay, so the crime attack was performed in 2012, and that was a heavy blow to the compression technique used in HTTP 1.1. one. So we'll see, before getting into this header compression which is used in HTTP2, we'll see how the attack was done. We all know what cookies is. Cookies is, if we try to understand what cookies is, in cookies we'll try to understand what authentication cookies is. Let's say I will take an example of facebook.com. What I will do is, for facebook.com, first I need to sign up with a particular username and then password. Username and password, I will sign up and at the facebook.com at the server end, it will generate a hash code for corresponding username and password and store it in database. Okay, it won't store as a plain text in its database. Now I have a hash code stored in the database. Now on the other hand, the client end, I have signed up. Now time to log in. What I will do is, I will send the username and password again to the server. Server will again generate a hash code. It will match with the hash code which is already present in the database. If it is matching, you can log in, else it will send some error. Now it is not about logging once, but being logged in for a particular session. Okay, so for a particular session to be logged in, what the server will do is, it will provide an access token. It will provide an access token, and then it will send back along with the cookies to the client. Now whenever the client is making a request, it will send the cookies which has access token to the server. So I won't be using username and password again and again. I will be using the same cookies to stay logged in for a particular period of time. They can set the expiry of the session, but still they don't need username and password. Okay. Now the attacker tried to attack these authentication cookies. How they attacked is, see, there are two things. Crime attack is a combination of plain text attack plus information leakage. Okay, now how they did this attack is, first they should have control on your network. Okay, second, you would have visited some random site, and with the help of that they have injected some crime JS file. Okay, we'll see what crime.js file does is, it will make multiple request to the target site, multiple requests to the target site. In that request, okay, what it will do is, first we see what deflate algorithm does. Deflate is nothing but if there is some redundant bit in your code, then it will compress and decrease, and the size will decrease. Let's say there is some text, and then you pad it with some text, let's say A. Now if A is already present in this secret text, then the size of the output size after compression will decrease, because A is redundant and is present on the secret text. This is how deflate works. Now information leakage. Information in TLS, you can see the size easily. That is not an issue. So what they will do is they will make multiple connections, multiple requests, okay, which will try to guess your authentication cookies. So you have some authentication cookies which is secret. Then what you do is you pad with some random word, let's say secret plus A. You make a connection 1, request 1. Then you make request 2, secret plus B, request 2. Then you make request 3, secret plus C. If the secret contains A, B or C, then the size will decrease. But the size of B and C will be greater than the compressed size of request 2 and 3, which contains B and C, will be greater than request 1. And that way they can guess that this secret cookie contains A. And we'll be using brute force, no doubt, but that way they can guess that they contain A. And similarly they can guess the content of secret cookie. Okay, this is crime attack. So what they did is they designed a new compression technique called HPAC. Okay, HPAC is nothing but it is using Huffman coding, static Huffman coding, not adaptive, static Huffman coding. Static Huffman coding has no known security vulnerability. I said no known security vulnerability. Okay. We don't know if they exist. Now there are few terms which we need to understand before getting into this compression technique. Static table, dynamic table, and Huffman algorithm. Static table is something like, see, if you have, we are dealing with header compression. So if you have, I will get you to this. This I took from blog.cloudflare.com. They have explained it beautifully. See, in request 1, see there is one static table which has the well-known field and value. Okay, if I say method get, this is a well-known and standard field and value. So this can be stored in some table like static table, and then instead of telling method get, I will be telling a reference let's say 2, I'll be telling 2, and the server, it see static and dynamic table is maintained at both ends, the client and server both ends. So if I say method get, the other end will if I say 2, the other end will understand 2 means method get. It will look into the static table on its side, and then it will understand it as method get. But there are few things which might not be stored in static table. Let's say blog.cloudflare.com. So this thing cannot be, it is not a standard, and it is a dynamic thing. So what they will do is, the green thing which you see, the green thing, they will compress it using Huffman coding, and then they will store it in a dynamic table. The red thing, request one, if you see request one, there is this, the red thing. Red thing is already present in static table. These are standard things which can be present in static table. And then we have this green thing. Green thing is nothing but they are using Huffman coding and compressing it, and then storing it in dynamic table. Now if you come to request 2, the first field, that is authority, it's already there in dynamic table. So here also you don't have to make any, you don't have to send authority, you simply can send reference. And the red thing in request 2, the red thing is already there in static, the blue thing is already there in dynamic table. Whatever is left, we will compress it using Huffman. So this is how the HPAC compression works. Okay. Now coming to the JDK9 side, we have this JEP called JEP 110. In JEP 110, we had this API called HTTP URL connection. But HTTP URL connection had some issues. Okay, no doubt it was using HTTP 1.1, so we had to move to some better APIs, okay, which uses HTTP2. So if you see this, we have 4 new APIs introduced with this JEP 110, but one thing to notice is this is in incubator mode. Incubator is something like experimental feature. We have 4 APIs. Those are HTTP client, HTTP request, HTTP response, WebSocket. HTTP client is something, is a client. We are getting a client, and then this client can send synchronous and asynchronous response. If I say client.send, and if I say client.send async, with the help of client.send async, you can send asynchronous response. And but for asynchronous response, you will need completable future in order to send asynchronous response. In request, if you see HTTP request, you need to set the URI where you want to send the request, then header, and then body. Okay, if you are if you are using a post method response, then HTTP response, you can get back the response status code body, and if you want body, that if you want the response, you can get it in as string or bytes. It's up to you. And then WebSocket. WebSocket is like, it's specifically for browsers which are and connecting to application server. Okay. Now we will see a small demo, okay, on these APIs. Okay. First demo is I will be using on this browser. Most of the browsers are supporting HTTP2. If you want to see, you can see it as if I say google.co.in. Okay, and if I say inspect element, okay, so if I say inspect element, go to network, and I will reload this page. Okay, if you see the initial get request that was made, okay, see, you see here, this is HTTP 2.0. Yeah, I have made a get request, and the request, this is a request header, and this was made with HTTP 2.0. So the browser is making a, most of the browsers are supporting HTTP 2.0. Okay. Okay, now we will see a small demo on the APIs which are introduced by JEP 110. Okay, so this is we'll see how it works. So we'll have a simple HTTP client equals to HTTP client dot new HTTP client. Okay, then we'll have request. We'll have request dot new builder with URI. Okay, URI I will be using Google. Okay, dot whichever method you want to specify, get post. So here I want a get method, and then build. I want to build this thing. Now I will have HTTP response, and I want this as a string. Okay, then response HTTP response HTTP response HTTP sorry client will be making a request. So client dot send request, and then body handler. Okay. Body handler I want as a string. Okay. Now I can get the output as C output. Okay, I want the status code. Okay, status code response dot status code. Okay, okay, so we have status code, so we'll get the body. The body response dot body. We can do one more thing. We can get the version of the response, HTTP version of the response. So response dot version. Okay. One thing to notice is, like, this is in incubator, so while compiling you will have to say javac add module jdk incubator. Okay, and then similarly while running We'll have to specify. If you see the configuration which I have set, I have added VM option as add modules, JDK incubator, HTTP client. While compiling and running, you have to include this both the time. Now compile. Okay. Then let's run this thing. Okay. So you can see this thing. You can see here, right? The status code is 200. Then the version is HTTP2, and body is nothing but a HTML file. Okay, guys. So this is all about HTTP2. We can go into more deeper into this any of this subtopic if you want. Thank you.